So let me mute. Anybody having questions? Because I see some microphones here. Okay, let me switch off the microphone. Okay, and good morning, everyone. Welcome to the first day's course. And on Tuesday, we have a quick look of vectors, and we say that vector forces are vectors, and vectors and scalars are different because vectors have directions. But in this book, we call it line of action and sense. Line of action and sense, but in general, it means direction. I also talk about how to mark these vectors, how to write these vectors down. Notation only means I should write this. Sorry. So this is how should we write vectors, especially for some professors that they like you writing it in this way. And we talk about negative vectors. So negative vector, of course, it has the same magnitude. Magnitude is this one, and they have opposite directions, but the key point is they have the same line of action. Is that okay? So they have the same line of action. And we talk about addition of vectors that some of you pointed out, some of you have told me that we can use parallelogram or triangles to add vectors. And we did an example here. In the future, if you see any questions, look for this word, find this word, find this word, and then you know what to do. And so we stop at sample 2.2. I translated some keywords in this question. Of course, this is rope. So, are you fine with the question? If you are fine, that please raise your hand. Okay, thank you. Then I will lower the hands. So let's start solving this problem. And determine, the word determine is here. So we do part A first. So we determine the tension in each rope if alpha equals to 45 degrees. Alpha 45 degrees. So we first the tension in each rope, we have two ropes. So we have two numbers. We have two unknowns. So we first write it like this. I'm sorry, I should write this word more clearly. So, does anyone have problems with my writing? you can write on the chat box, or you can say it either in Chinese or English. So let is and we because we are going to determine the tension in rope 1 and rope 2. So we give them names. We give them names. And because this one refers to this thing, this one, and this one refers to this one. So in Chinese, we would say this. In English, it is respectively. So the accent is here. The word is this one. Can you see clearly? RESPECTIVELY. Is that? If you have any problem, then raise your hand or type it in the box if you have the box. And so we next we go to, so any problem you can say in Chinese if you want. 子云是不是有什么要帮忙的地方？
没有，我按错了，抱歉。
没关系 ，OK， 没问题。好，我先把手放。Okay. So if after we give them names, that we can draw the figure. So we have T1 with 30 degrees. T1 30 degrees, and then we have T2 of 45 degrees. We don't know how much is T1 and how much is T2. We know neither of them. But what do we know? We know what do we know? Can anybody tell me? Of course, you can see in Chinese. We read the question again. We read the question again. Is the resultant of the forces is a 5 kN force directed along the axis. Axis. So axis of the barge. So axis is this one, of course, because it is moving along this direction, moving to the right. So the resultant. You remember what resultant is, right? Resultant. So the resultant is 5 kilonewtons towards the right. So we have this one. Or should I write it, draw it shorter? So is that clear? That I'll give you some time to draw the figure. I think it will not be a problem to you. I think you will be able to do the calculations after I explained it. So it is somewhere like this. And to draw it, and you can, I will do it this way, and this is the way the textbook is doing. So this is and the resultant is 5 kilonewton. Five kilonewton is here. And then we have T1. T1, we don't know how much is T1, but we know that it is going towards 30 degrees, right? And then we are drawing something like this. We want to draw something like this. T1 and T2. So, and for T2, we don't know how much is T2 either. So we draw the direction. We draw a dashed line. We draw a dash line. Dash line is this one. So we draw a dash line along the direction of T2 because we know it is because we know it is 45 degrees, right? And of course, this is 45 degrees. Is that okay? For these figures, I recommend. I think you should draw it by yourself. You can draw it on the handout. You can draw it on any piece of paper. Try to draw them. So this one represents T1, this one represents T2. This dashed line represents T1 and this dashed line represents T2. After you draw the figure, that please raise your hand and let me know. Thanks. Good. So for those who, let me see. problems. If I say I want to give you time, then I want to give you enough time for you to draw. So after, so I'll wait until more people, more of us have finished copying the figure. From my experience, if your for your seniors, that if they get the figure wrong, that they will their calculation will be wrong and the answer will be wrong. So if the figure is right, that there is that there is hope that the answer will be right. But if the figure is wrong, that the answer will always be wrong. And that is my experience, and just to share with you. So if I assume most of you have finished copying the figure. If you have if you want me to give you some more time, let me know by giving anything giving me other symbols. So I assume most of you are all right. So let me lower the hands. Let me go on. So if we do it, that we know this. This is like it's a triangle. It's a triangle, and we have we have the length of one side is known. We have two angles, and of course we can use whatever. You can use any of the laws you have learned at high school. So I choose this. I choose the law of sines. So we have 5 kilonewton over sine 105 degrees, T1 sine 45 degrees, T2 sine 30 degrees. So you can do your calculation, and but we have like this. You can check them. You can check them using your calculator. One remark here. If we are marking tensions, you don't need to give the direction in the answer. Is it okay? If we are determining tensions, we don't need to mark the direction. For other forces, I let me go back to page 5. For other forces, we have this thing, or on page 7, on page 6, we had this thing. We had this thing about the direction, but in But on page 7, because we are marking tensions, we don't need to put direction is not required in the tensions. Okay, you say okay. So if you have finished copying this, or if you are fine with my explanation, please raise your hand and let me know. Thank you. For the others, I will give you some. I'll give you a bit more time to get this right. So are the others okay? I see half of the class have not raised their hand. Are you okay? Yeah, I cannot see you, so please let me know if you are fine or not. Okay. Thanks for letting me know, and I will lower the hands and I'll go on. So, and we go to part B. What is then part B of the problem? Part B. Part B is we determine the value of alpha. We determine the value of alpha, but which alpha? It says which alpha. It gives a hint. It gives a hint where tension of rope BC is minimum, because as you can imagine, for this one and for this one, if alpha equals to 45 degrees, that we have a value of T2. If we have another value of T2, we have it seems that if we have a very small angle alpha, we have a large value of T2. And if we go to go there, if the angle of alpha is nearly 90 degrees, the value of T2 is also quite high. So we want to determine the value of T2 if we want to determine the value of alpha where T2 is minimum. So we go like this, and I think let me. So we have we still have this 5 kilonewton, and then we still have that T1. Oops. -30 degrees and T1. So we have let me show you before I draw something solid on this piece of paper. It seems that this is not the answer. This is not the answer, right? Because this one is smaller. This one is smaller because we are finding the shortest distance between this point and this line. The shortest distance between this the points and a line. So what do we know from mathematics? The shortest distance between a point and a line is when this one is 90 degrees, right? So if the angle I mark is 90 degrees, this, how much is this one? Does anybody know? You can type it in the box or say it in Chinese or English. I assume you know. How much is it? How much is it?
2.5 kilonewton.
2.5 kilonewton is 2.5 kilonewton is the force. Wait a minute. Right, 2.5 kilonewton is the force. But how about alpha?
60 degree.
60 degree. Very good. So alpha is equal to 60 degrees, right? So but let me write down the this is the answer. Of course, this is the answer. But let me write a line explaining this. T2 is minimize. Say if you want to use Z, okay. If the lines of action of T1 and T2 are perpendicular to each other. You can copy it. I'll give you some time to copy this. This is this one. Can you read it? Can you read it clearly? If you can read it clearly, that give me a thumbs up or raise your hand. Good, thank you. So please take a bit of time to write it down. Wait a minute. Okay, let me lower the hands and I need to. The department, the university is asking me to capture the screen of this line meetings, of this Teams meeting. If nobody's showing your nobody's giving. Oops. Nobody's showing your camera, so it should be okay. So and I'm sorry, and I was away. So can you see the screen now? If you can see my iPad, so give me. Please raise your hand. And wait a minute. Wait a minute. Let me copy link. Give me a minute to sort out some things. I need to. Okay, sorry. And okay, thank you. And I will lower the hands. So for the if you don't understand my English, at least you write with me, and then I when I do my end of class explanation, that you at least you have something to follow. Okay. So we go to the next page. We go to the next page. Page 8. So we are talking about in the textbook. It has a strange name of like resolution of force into components. It essentially means breaking down. So it essentially means break. Can you hear me now? Okay. So I assume you can. Okay, good. Some of you give a thumbs up. Thank you. And it essentially means breaking down a force. It means breaking down a force. So in this case，
老师，你是不是没有分享荧幕？
哦，对，刚刚发生什么事情？不好意思。Let's go to page 8 and where is it? Sorry. Just give me a minute. Give me a minute. Is it okay now? Good. Okay, thank you. And having an iPad solves 99% of the problems, but sometimes there is 1% of the problem that sometimes I miss it. So in this problem, F is known, and P and Q are unknowns. It's okay. F is known and P and Q are unknowns. So you can but in this case that we have how many combinations? Do we have combinations? Is this one, and the infinite number is this one. So we have we have an infinite number of combinations. We have an infinite number of combinations. So why do we study this, or how can we study this? What should we do? What should we do? So we are only consider, or we are only looking at 2 cases. We are only looking at 2 cases because in this one is F, for example, and these ones are P and Q. Of course, you can draw another set of P and Q like this. I think this is, you can imagine this, right? So we have, therefore, we only take 2 cases. One is either P or Q is known to we have we consider these 2 cases. One of them is either P or Q is known. For example, we know P, and then we find Q. We determine Q. P is known, and then we determine Q. Or we know the lines of action of P and Q. We know P is in this direction and Q is in this direction, and then we determine P and Q. Is that okay? So if you have finished writing these down, give me a please raise your hand. Thank you. So if you are fine that I will stop recording and do some revision.